Can life exist elsewhere in our solar system? After years of asking this question, scientists are really eager to find the answer. Meet Europa, one of Jupiter's 4 Galilean moons discovered in 1610, and the 6th largest moon in our solar system. I'm Johnny, and this is Absolute Zero, a series of short videos about science. This cold, icy world can be seen from your backyard with an amateur telescope, or even a set of binoculars. In the search for life beyond Earth, Europa is really in our own cosmic backyard. In the first episode of this series, we looked at an image of Jupiter taken from the James Webb Space Telescope, and in that near-infrared image, we were looking at the telescope's ability to track objects. So we had a couple of great surprises. We got to see the rings of Jupiter, and we also got to see Europa. And not only that, we also got to see the shadow of Europa cast on the surface of Jupiter. This certainly is not the first time that we've had a close-up of Europa. In fact, right now we have the Juno spacecraft. It's currently orbiting Jupiter, and it's studying the gas giant and sending us some really incredible data and images. The clearest images that we have of Europa actually come from the Galileo orbiter. The Galileo orbiter made 12 close passes and provided some really substantial evidence of an ocean, a liquid ocean existing beneath Europa's icy crust. So how much water are we talking? Well, the best guess is that there's roughly 2 times as much water as we have here on Earth, and in 2030 we might start getting more definitive data. NASA has a mission in the works. It's called the Europa Clipper. It's set to launch in 2024 and orbit Jupiter, making some very close passes by Europa. The mission has 3 main science objectives. We'll be learning a lot more about the surface and crust and how they interact with the ocean beneath, and with that, we'll be determining the properties of the liquid ocean, like its size and saltiness. Scientists will also characterize the geology of Europa's surface and locate any signs of recent activity, like plumes that may be venting water out into space. Finally, scientists will investigate Europa's composition and determine if this mysterious world has the ingredients to permit and sustain life. That is the main science goal. In the past, we've had this idea that life can only exist under a very particular set of circumstances. For example, the Goldilocks zone. This is a range of distance from a star in which water can remain liquid. The more we poke around, even in our own solar system, we're realizing that some favorable conditions can exist in very unsuspecting places, like beneath the icy crust of a moon, orbiting a gas giant millions of miles beyond the habitable zone around our sun. Hopefully, the Europa Clipper mission will change the way that we imagine life. And perhaps this gives hope for some favorable conditions existing elsewhere in our solar system, like on Jupiter's Ganymede or Saturn's Enceladus. Let me know in the comments what your favorite moon in the solar system is, or if there's any topics in physics or space that you think I should cover in a future episode. As always, follow along as we journey through space and time.